The other important terms that you should familiarize is peak factor and form factor. So the first term, peak factor. Peak factor is defined as the ratio of the maximum value to the RMS value of any alternating quantity. The alternating quantity, it could be either a voltage or current. This peak factor is also known as crest factor or amplitude factor. It is usually denoted as capital letter K, suffix small letter P, Kp. So the peak factor may be written as Em by ERMS or Im by IRMS or Vm by VRMS. It is a dimensionless quantity, meaning it doesn't have any unit. Here I have stated an example to find the peak factor for a sine wave. As you may see, it is maximum value divided by RMS value. So you get the value as root 2. The next important term that you should learn is the form factor. It is a ratio of RMS value to average value of an alternating quantity. Again, the alternating quantity could be either a voltage or current. It is usually denoted as capital K, suffix small letter f. So by mathematically it is expressed as form factor is IRMS divided by I average or VRMS divided by V average. Again, for a sine wave, I have calculated the form factor, the RMS value divided by average value, that is Im divided by root 2 divided by 2Im by pi. So you get it as pi by 2 root 2. So now I have calculated the RMS, average, peak factor, form factor for all these waveforms and tabulated it. So you may see the sine, the peak factor is root 2 and pi by 2 root 2, which is same as full wave rectified output. For half wave it is 2 and pi by 2. Similarly for the other waves, square, sawtooth, triangular, you may find out and complete the table. So now let's try to solve a figure and find out the RMS value, average value and form factor. So this is actually a combinational waveform. From the time 0 to 10, it is a sawtooth waveform. From 10 to 50 seconds, it is a rectangular waveform. And from 50 to 55, it is again a sawtooth waveform. And the maximum value or the amplitude is shown as 20. So in order to calculate the RMS value, you need to split the time intervals from 0 to 10, 10 to 50, 50 to 55. So the equation becomes square root of 1 by 55. For integral 0 to 10, that is basically a sawtooth waveform, you need to find the function v of t using the slope equation. V of t is equal to Vm divided by t into t. Here in the question, Vm or maximum value is given as 20 and the time period is 10. So it becomes 20 by 10 t the whole square dt plus the second time interval 10 to 50 is a rectangular wave. A rectangular wave meaning it is a constant value just like a DC. So it is Vm itself. The function v of t will be Vm, that is 20. So it becomes Vm square or 20 square. Next is 50 to 55. It is again a sawtooth waveform, but in the opposite direction. So you have to take y is equal to minus mx, or the slope becomes minus 20 by 5. So v of t function becomes minus 20 by 5 into t the whole square. Now simplified, you may get the answer as 65.78 volt. You must specify the unit for RMS and average value. Next is how to calculate the average value. Since it is an non-sinusoidal waveform, you may use the simplest equation, that is area under the curve divided by the time period. Here the curve is split into 3, so you need to sum the area of the 3 curves. First is a sawtooth, second is a rectangular, again the third one is the sawtooth. The sawtooth area is half BH, so it is half into base is 10 into height is 20. plus rectangular. Area of the rectangular is length into breadth, that is 40 into 20. Plus again the right angle triangle area, that is half BH. Half into 5 into 20 divided by the whole time period, 55. So you get the answer as 17.27 volt. Now the form factor Kf is the ratio of RMS value divided by average value. So you get it as 3.8. It is a dimensionless quantity, meaning there is no unit for it. So similar, a lot of problems are solved in the Navas textbook. Please refer to all those problems. Usually this kind of combinational waveforms will be asked for your exams. If you have any doubt, please feel free to ask. Thank you.